Good morning, student. We know already the free particle in one-dimensional box up to calculate the wave function, that is psi x equal to a sin n pi x by L. Here L is the length of one-dimensional box. The value of n is n equal to 1, 2, 3 like this. The a is the constant and psi x is the wave function when the free particle present in one-dimensional box. Here a is the constant and the value of constant calculate by using the normalized condition. Use the normalized condition. We know the integration over all the space of probability density over volume dV is equal to 1. We know in the previous theory the normalized condition of wave function. Use that is the normalized condition. Use the 0 to L psi x square dx is equal to 1. This is the normalized condition. In case of the one-dimensional box, the lower limit 0, upper limit L, because the length of one-dimensional box is L. Put the value of x, we get 0 to L. The value of psi x is, wave function is a square sin square n pi x by L dx is 1. That is a square 0 to L sin square n pi x L dx is 1. Then that is here a square by 2 0 to L 2 sin square n pi x by L dx, writing in this way. That is using trigonometric relation a square by 2 0 to L, that is 1 minus cos 2 n pi x by L dx is 1. The value of second integration is 0. Therefore, but value of second integration is 0. Therefore, a square by 2 0 to L dx is 1. That is a square by 2 x 0 to L is 1. That means a square by 2 L is equal to 1. That is a square equal to 2 by L. That is a equal to 2 by L to the power half. This is the value of constant A. Therefore, the wave function write down by putting the value of A, we get the psi x is equal to 2 by L sin 2 by L to the power half sin n pi x by L. Then here observe the equation 6 and 7 give the value of wave function of free particle when it is present in one-dimensional box. Then we find out the eigenvalue of propagation constant, eigenvalue of momentum, eigenvalue of energy. Here we know the value of k is nothing but n pi by L. This is the value of k. It is nothing but propagation constant. Where the value of n is 1, 2, 3 like this. When we put n is 1, we get the value of k is pi by L. When we put n is 2, the value of k is 2 pi by L. When we put value of n is 3, the value of k is 3 pi by L. And these are called the eigenvalue of propagation constant. Eigenvalue of propagation constant. Then we find out the eigenvalue of momentum. Your image, we find out eigenvalue of momentum. We know the k is nothing but p square by r, k is nothing but p by h cross. Therefore, p is nothing but kh cross. We know value of k. K is nothing but n pi by L and h cross. Therefore, when we put the value of n is 1, 2, 3, we get p is nothing but pi h cross by L. P when the n is 1. When we put the n is 2, we get 2 pi h cross by L. N is 2. When we put the value of n is 3, in this equation we get 3 pi h cross by L, that is n is 3. And these are called the eigenvalue of momentum. Eigenvalue of momentum. These are called the eigenvalue of momentum for free particle when it is present in one-dimensional box. Then find out the eigenvalue of energy. We know from previous theory the value of energy, that means here we know twice me by h cross square is nothing but k square, and the value of k is nothing but n pi by L, that is n square pi square by L square. Therefore, E is nothing but what? E is nothing but n square pi square h cross square by twice m L square. This is the value of kinetic energy of free particle when it is present in one-dimensional box. Then we find out the eigenvalues of energy. When we calculate the eigenvalue of energy, this is the expression of energy of free particle when it is present in one-dimensional box. Put n is 1, we get E1 equal to pi square h cross square twice m L square. When we put n is 2, we get E2 is 4 pi square h cross square twice m L square. When we put n is 3, E3 equal to 9 pi square h cross square twice m L square. These are the energy values. Here the E1, E2, E3 are called the eigenvalues of energy of free particle when it is present in one-dimensional box. Then the many times the question asked in exam, this is called the wave function of free particle when it is present in one-dimensional box, and these are called eigenvalues of energy when the free particle present in one-dimensional box. The question is, what is 0 point energy? Many times asked. For 1 mark, what is 0 point energy? The lowest energy is nothing but the 0 point energy, because when the particle present, free particle present in one-dimensional box, its energy does not 0. E is not equal to 0 at absolute 0 temperature. At absolute 0 temperature. Therefore, the lowest value of energy when you obtain, when you put the n is 1, we get E1. We get E1 equal to pi square h cross square twice m L square. This is called 0 point energy of free particle. This is called the 0 point energy of free particle when it is present in one-dimensional box. Therefore, the today's lecture, we know the wave function of free particle when it is present in one-dimensional box, the eigenvalues of propagation constant, eigenvalues of momentum, eigenvalues of energy, and 0 point energy. And today stop here. Thank you.